Hi, algebra students. Today our learning target is that I can graph a rational function using transformations. Now, real quickly, what you need to know is that on your note packet at home, you do not see the LT on there, and you only see it starting with number 6. So just make sure you're on the right page with me before we begin, okay? Well, let's start off with what is a rational function that you're going to be graphing today. Today, the rational function that you'll be graphing today looks like this form. Y is equal to A over X minus H plus K. And we're going to be using transformations to learn how to graph that. Now, on number 6, this is on your parent graph worksheet. It should be, and if it is not, you have it here. Here is our parent graph right here. Y is equal to 1 over X. So we're going to start with the table over here. And we see that X is equal to -1. We're going to plug -1 into X right here. And when I do 1 over -1, that gives me a Y value of -1. Okay? 1 over -1 gives us a Y value of -1. Now, next what I'm going to do is I'm going to plug 0 into X right here. When I take 1 over 0, I want you to type that into your calculator for me. Pause it right now and see what you get. You should get an error. When I type 1 over 0 in there, that's an error, which means when X is equal to 0, our Y value is what we call undefined. So I'm going to put a UND there. Next, what I'm going to do is I'm going to take, when X is equal to 1, I'm going to plug 1 into X, and I get 1 here. And then finally, when will Y be equal to 0? Okay? When will Y be equal to 0? If I look over here, I want to know what value will make Y equal to 0. What value of X will make Y equal to 0? Well, guess what? Because we have this 1 up here, that will never, and the X below, that will never happen. So what we do is we put undefined right here. And right now what we have right here is we have our parent table that accompanies our parent graph right here on number 6. Okay, so let's go ahead and let's start graphing these points. Let's first look at -1, -1. So on my X here and I have my Y, -1 is right here, -1, and I have a point right there. Next, let's talk about 0. 0 undefined. What does that mean? That means I have something called a vertical asymptote on X equals 0. Because what that means, ladies and gentlemen, is Y will never be a value there. Our graph will never touch that, okay? So that is our vertical asymptote at X equals 0, okay? At X equals 0, we have our vertical asymptote, okay? Next, let's talk about when X is equal to 1, Y is equal to 1, so that's right here. And then finally, we have this right here, this undefined 0. That means when Y is equal to 0 right here, we can never, anywhere really on this line, Y is equal to 0, we can never have a point there, okay? We can never have a point there, and that's called our horizontal asymptote. Okay, let me just spell asymptote for you over here. So VA stands for vertical asymptote. And then HA stands for horizontal asymptote. So we have a horizontal asymptote at Y equals 0. Okay, now what is this graph going to look like? Our parent graph is going to look like this. This approaches, okay, curves again and approaches this X equals 0, and then just like that. So it never touches those horizontal or those vertical asymptotes this is what our parent graph looks like. Now let's talk about our domain and range. When I'm thinking about our domain and range, when I think about my domain, I'm kind of going left to right, looking at my graph left to right like this, and I'm saying, where can my domain, or where does my X value not work? Well, my domain can work everywhere but, everywhere but when X equals 0. So I'm going to put X cannot equal 0, okay? My domain, X cannot equal 0, but it can equal 0 everywhere else. Okay, so what we know is X cannot equal 0, but it can equal all other reals. So what I'm going to put on top of this is I'm going to say all reals, so all real numbers, but X cannot equal 0. Now let's talk about the range. The range is all the Y values up and down that we can have. So is there anywhere in the graph where we can't have a Y value? And we can't have a Y value at Y equals 0. So we can have it everywhere else. Okay, so we're going to put all reals, meaning all real numbers, but Y cannot equal 0. Okay, so what do we have here? We have our parent graph. We have our table that goes with it. We know what that graph looks like. We've talked about the domain. That's all the X values that will work for this graph. We've talked about the range, all the Y values that will work for this graph. We've also talked about what that vertical asymptote is and that horizontal asymptote is. Let's go ahead now and let's start graphing some different rational functions using transformations. Okay, so what I did is I talked about now our form. And we said y is equal to a over x minus h plus k. Okay, now when we've been using transformations, we have first step, we've been doing the parent table. So let's go ahead and let's look at this parent table. We're going to take this table right here and we're going to transfer it over to our first equation. So we're -1, -1. Okay, when x is 0, okay, when x is 0, our y value is undefined. When x is 1, our y value is 1. And when y is 0, well, our x is undefined. Okay, there is no x value that will make our y equal to 0. Okay, next, what we've done once we've had our parent table, so that's step 1. Remember, I'll write the steps over here first. I'll put PT for parent table. Step 2, we are going to transform the graph, the table. We're going to look at that table and we're going to use transformations to change the table. Now, I want you to remember, this is key. We've talked about this before. We've talked about when we have this something happening on the inside, what do? We do the opposite operation to x. When we have something on the outside, we do the same to y. Now, ladies and gentlemen, this looks a little different because we don't have an inside. There's no grouping symbol. So what is the inside? Whatever's happening in the denominator, that is considered the inside in our function. Anything else is on the outside of our function. So we have our table. Step 1, we got our parent table written down. Step 2, we're going to use transformations to change this table. We're going to say, is there anything going on in the inside? The inside is that denominator right here, x minus 3. So we are going to do the opposite to x. The opposite to x, that means we're going to add 3 to all of our x values. We have -1 plus 3. That's going to give us 2. That's gone. We have 0 plus 3, that's going to give us 3. 1 plus 3, that's going to give us 4. And then undefined plus 3 is still undefined. Okay, next, let's see, do we have anything happening on the outside of our function? Nope, the 1 is still the same as our parent graph, so we don't do anything to y. So now let's go ahead and let's graph our points. At 2, -1, this is our first point here. I'm going to go to 2, and I'm going to go to -1. I'm going to put a point. 3, undefined. That means when x is equal to 3, our y is undefined. So I'm going to go to x equals 3, 1, 2, 3, and I am undefined here, guys. This right here, sorry, it's a little off there. This right here is our vertical asymptote. X equals 3. Next, I'm going to go to 4, 1. 4, 1 is right here. And then finally, I want to go to undefined 0. That means when y is 0, okay, when y is 0, our x value is undefined. It basically just means, guys, we have a horizontal asymptote when y is equal to 0, okay? We have a horizontal asymptote when y is equal to 0. So let's put y is equal to 0 right there. Next, our parent graph is going to look our transformed graph is going to look the same as our parent graph. So we're going to swoop up here, down, swoop over, and down. It should look kind of curved there. And let's talk about our domain and range. Our domain is going left and right. What's happening? Where can I not have an x value? I cannot have an x value on x equals 3. But I can have any other number. Any other x number I can plug in, but x cannot equal 3. For the range, I can have any number, but not y equals 0, okay? I will never have an x value when y is equal to 0. All right, let's move on to our next one. Oh, describe the transformation, you guys. I'm sorry we didn't do that. When we describe that transformation, then finally, what we want to do is when I say, well, what happened? We moved to the right 3 spaces, or 3 points to the right. Let's say 3 points to the right. I think some teachers just say to the right 3 as well, okay? To the right 3 as well. Okay, let's move on, guys, to the next problem. We've transformed right 3 on the last one. Sorry, someone just walked into my classroom. Let's go ahead, step 1. Let's fill out that parent table graph. So -1, -1. When x is 0, we are undefined, okay? When x is 1, we are at 1. And when x is undefined, meaning we can't have it, y is equal to 0. Okay, next we want to look and we want to talk about transforming the graph. Is there anything going on inside the denominator? No, there's not, so we don't do anything to our x value. Remember, inside we do opposite to x, okay? Nothing going on inside. Do we have anything going on outside? We do. The 1 is the same from the parent, but the 5 is a +5. So we do the same operation to y. So what we're going to do to y is we're going to add 5 everywhere. Okay? So -1 plus 5, that gives me 4. Undefined plus 5 is still undefined. 1 plus 5 is 6, and 0 plus 5 is 5. All right, ladies and gentlemen, let's go ahead. Let's graph these points now. Okay, at -1, I'm at 4. -1, 1, 2, 3, 4, I have a point. At 0, I am undefined. So when x is 0, I will not have a y value. This is my vertical asymptote. When x is equal to 0, okay, I do not have a value. That's my vertical asymptote. Next, let's look when x is equal to 1. Y is equal to 6. X is equal to 1. 1, 2, 3, 4, 5. Whoops. 1, 2, 3, 4, 5, 6. And then finally, when X is undefined, okay, Y is equal to 5. So when Y is equal to 5, we will not have a value for X right there. 1, 2, 3, 4, 5. When Y is 5, we will have no value for X here. Okay, when Y is 5, no value for X. What does the graph look like? The graph looks just like our parent table. Or our parent graph, excuse me. Let's go ahead. We know that we have our horizontal asymptote now at Y is equal to 5. Our domain is all reals. I'm going to use this, okay? But now hopefully you're seeing there is a theme. We look at our vertical asymptote and we just say, hey, it can't be there. The range, it can be all reals, but not whatever our horizontal asymptote is. Okay, let's move on, guys. Let's do f of x is equal to 1 over x minus 3 plus 2. I'm going to go a little bit faster because we've gone through this now. Negative 1, negative 1. When x is 0, y is undefined. 1, 1, undefined. Okay, right, undefined, and then we're at 0. Okay, next step, what am I going to do? I'm going to look and say, is anything going on inside? We do have a minus 3 on the inside, so I'm going to add 3 to everything. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And undefined is still undefined. On the outside now, I do have a plus 2. Okay, negative 1 plus 2 is 1. Undefined plus 2 is still undefined. 1 plus 2 is 3. And 0 plus 2 is 2. Next, what I'm going to do is I'm going to plot my points. When x right here is 2, y is 1. X is 2, y is 1. When x is 3, y is undefined. 1, 2, 3. Here's x is 3, y is undefined. We will never have a y value here. Okay? When x is 4, y is 3. 1, 2, 3, 4. Y is 3. 1, 2, 3. When y is equal to 2, x is undefined. So when y is equal to 2, x is undefined. So I'm going to go to y is equal to 2. 1, 2. X is undefined right here. And this looks like my parent graph. Curves. There we go. Let's talk about our horizontal asymptote. Our horizontal asymptote, well, let's actually start with our vertical asymptote. That's what we started with first. Our vertical asymptote is that x is equal to 3. Our horizontal asymptote is right here, right? Right here. When y is equal to 2. And remember, our domain is all reals, but it can't be what the vertical asymptote is. And this little double R right here, it's like this, an R with a line going through it, that means all reals. So all reals, but x cannot be 3. And then the range is, again, all reals, but we can't have what the y value is. But y is not equal to 2. Describe the transformation. What happened? Our graph moved to the right 3. Okay, our parent graph moved to the right 3. You can see that by our addition of 3 over here on the table. And it went up 2. And we can see that by the addition of 2 over here. All right, let's move on, ladies and gentlemen. 6 over x. Okay, so what's going on this one? Again, I'm going to go a little bit faster because we've gone through it. And let's just talk. We have negative 1, 0, undefined, 1, 1, undefined, 0. Is there anything going on inside? There is not. Is there anything going on outside? Yes. We have a 6 here in the numerator. That is a multiplication of 6 to get there. 6 was multiplied by 1 to get there. So we do the same to the y values. Anything in the numerator is a multiplication. I'm going to multiply everything by 6. So that's going to give me negative 6. undefined still, 6, and 0 still. I'm going to now plot my points at -1, 1, 2, 3, 4, 5, 6. 0, I'm at undefined. When x is 0 is right here. I'm undefined. There's no y value ever there. When x is 1, I'm at 6. Oh, ladies and gentlemen, I made an error. I'm so sorry. I'm going too fast now. At -1, I'm at -6. 1, 2, 3, 4, 5, 6. At 1, I'm at 6. 1, 2, 3, 4, 5, 6. And then if you look here, when y is equal to 0, okay, so y is 0 right here. My x values are undefined. Wow, what just happened? I just had a huge vertical stretch that happened. A big vertical stretch that happened. I'm not going to go through the horizontal, vertical, asymptote, domain, and range because I've already done that with you and we're at the 21-minute mark. And I want to do one more thing with you. We're just going to put the vertical stretch. Whenever we multiply something to the y's, we have a vertical stretch. A multiplication to the y's is a vertical stretch. All right, let's move on to one last problem here. Here we have our table over here on the opposite, -1, -1. Again, first step, that parent table, 0, undefined, 1, 1, undefined, right, 0. What's happening on the inside? I'm adding 3 again, so that means I'm going to do the opposite. I'm going to subtract 3. -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. Undefined minus 3 is still undefined. Okay, what's happening on the outside? On the outside now, that's in the numerator. I'm multiplying everything by a -2. So that gives me -2. Undefined by -2 is still undefined. 1 being multiplied by -2 is -2. And you guys, I'm going too fast. Let me slow down. -1 times -2 is a +2. Why is that? Well, a negative times a negative is a positive. -1 times -2 is a +2. 1 times -2 is a -2. And 0 times -2 is 0. Okay, next I want to plot these points. Here are my x value. Here is my y value. My x value is at -4, 1, 2, 3, 4. +2, 1, 2, right? That's a +2, okay? At -3, I am undefined. So 1, 2, 3. -3 is right here. My y values are undefined. When x is equal to -3, I have a vertical asymptote because my y values are undefined. When x is at -2, 1, 2, my y value is at -2, 1, 2. Okay? And when y is at 0 right here, our x values are undefined. This is my horizontal asymptote. Now, what happened, guys? Notice how the dots flip-flopped. Usually, we have our dots over here and here. That didn't happen this time. Why? Because this negative reflected, okay? This negative reflected our graph over the x-axis. So we had a reflection over the x-axis. That's what that negative in the numerator does to us. It reflects our graph over the x-axis to look like this. That 2, that multiplication of that 2 also stretched our graph. We had a vertical stretch. So what did we learn here, ladies and gentlemen? When we multiply by a negative to the y, we have a reflection on the x-axis. We also multiplied by that 2 there. That gives us a vertical stretch. Just like we multiplied by 6 over here, that gave us a vertical stretch. So that multiplication of something other than 1, right? That gives us that vertical stretch. Okay, finally, just to slow it down for us, let's talk about that domain. Our domain can be all reals, but the vertical asymptote. And I talked about that by looking at it right to left, up and down. And hopefully you've made that connection, as well as our range is all reals, but the horizontal asymptote up and down. I can't be at that horizontal asymptote. Y cannot equal 0. All right, ladies and gentlemen, step 1, make your parent table. Step 2, transform that table. Step 3, graph it and talk about your horizontal asymptote, vertical asymptote, domain, and range. And then finally, describe the transformation. There's one transformation that we have not addressed. We've talked about the multiplication of the negative, about the 2. We have not talked about this negative 3. What happened? Our x values went to the left 3. So the whole graph shifted left 3. Phew, we did it, ladies and gentlemen. Thank you for your time. It was a long one today. Make sure you let your teachers know if you have any questions.